I was harvesting some trees by the edge of the pond, so I bought a winch to pull the logs up the hill. Unfortunately, the winch broke after the first load even approached its rated capacity, so I'm not sure if this thing's garbage or if it just had a minor defect. It is under warranty, but they offered parts only with a lead time of 8 to 10 weeks. There's no way I'm going to get this job done before the sawmill shows up with that timeline. Luckily, I'm still in control of the situation with SOLIDWORKS. Let me show you what I mean. I opened up the winch and immediately noticed some metal shavings in the grease, probably from the corners of this gear, which seems to be some kind of a clutch. It's spring-loaded and extends or retracts when you turn the knob to engage the motor. There's a lot of moving parts packed in here, so I'm going to make some simple 3D models and assemble it in SOLIDWORKS to get a better look. I can use simple representations for most of these parts, but to create the gears, the Toolbox will just build them for me. Choose the type of gear, number of teeth, thickness, shaft, diameter, easy. Once I get the assembly all put together, I can see how it all works, and this tooth engagement is my main focus. So theory number 1, the clutch gear can't extend all the way because the grease and the planetary gears are in the way. I can measure the nominal clearance, but I want to study the tolerance stackups using TolAnalyst. I'll create a new TolAnalyst study, measure the gap I'm worried about, and then define how the parts are assembled and in what order. The mating faces and the dim expert dimensions are captured in the study and statistically combined to give me a final assembly tolerance. Minimum clearance comes in at about 60 thousandths of an inch, which should be fine for these high tolerance gears. So next I looked at the part that engages with this gear, and it's kind of recessed into the housing, which seems odd. Now, at full extension, the teeth engage by 180 thousandths of an inch. So is that enough? I don't know. I mean, I can answer that question with simulation. I just set up a study on a single set of teeth and do some quick math to figure out the force on each tooth, and in a couple of minutes, I was able to confirm that the rated load would cause material failure in the exact place where it failed. So I need these gears to have more engagement, and I can't move the clutch down any further into the gearbox, so instead I'll push that outer gear outwards and add a spacer to hold it there. And because it's in 3D, I can build the spacer I need right here and confirm it won't interfere with anything else. I can simply rerun the simulation on the modified assembly to confirm that the stresses are both below yield and away from the already damaged areas, so I can continue to use this damaged part until a new one arrives. Now for the spacer, it's a really small area on the end of this gear that's got to hold it, and some tight tolerances on all sides. There's no way I'm going to be able to find something like that off the shelf, so I'm going to print it on a Markforged printer. The parts are nylon based, so they can resist grease and high heat, and with onyx, the chopped carbon fibers in it give it strength and dimensional stability. Mine was perfect to 1,000th of an inch, and the print took less than 2 hours. So let's review. With SOLIDWORKS, I was able to quickly study the problem in 3D and test a few theories, devise a simple solution that I was confident would work, and with a Markforged printer, I made a precise and durable part. It was done the same day I started because I was in control. I didn't have to wait on anyone else. I mean, I could have waited months for those replacement parts, but they wouldn't have fixed the root cause, and I would have missed my delivery. Or I could have thrown money at the problem or hired a competitor to come do this job for me, none of which is really a workable option. If this equipment had local OEM support, I wouldn't need to go through all this, but a lot of big factory equipment can't sustain a local dealer network, especially old stuff. With SOLIDWORKS and Markforged, you can create a purpose-built solution center to solve almost any problem, big or small. No excuses. If you have manufacturing in-house, you'll be amazed at how much this combination can improve your operations by putting you back in control when something unexpected happens. To learn more about SOLIDWORKS, simulation, or Markforged printers, please visit our website at mlc-cad.com.